Okay, we're going to look at a short video on how to do some basic calculus procedures with the Calc 84, and then I'm going to finish that up by pointing out what I think is a pretty serious limitation to it, and see if anybody out there has a workaround for that. Okay, so this is the calculator oriented as it would look on a laptop. If you put it on a phone, it looks more like a traditional TI-84. And so if it looks a little disorienting to you this way, put it on your phone and it should look more normal to you. All right. So first of all, we're going to look at the button that says math, which the way I have it oriented right now is in the first column and the next to the last row down. So I'm going to click where it says math. And it's going to give me this menu. And so you've got a lot of different options here. What we're looking for here today is in the math menu. And so I want you to take particular notice of these functions. Function number 6, which is the inderivative, which computes numerical derivative. Number 7, which is function integral, which will compute a function integral that gives you a numeric value with a lower and upper bound for your limit of integration. You can do a symbolic derivative, and you can do a symbolic integral. Okay, so let me take you through, for example, doing a symbolic derivative. All right, so I'm going to click on function number 8. And so as you can see on my screen, I get dx. So in other words, I'm taking the derivative with respect to x, and now I just need to type in some function. So what I'm going to do is I'm just going to do a basic polynomial function. You know what? Let me do a polynomial function, a polynomial expression with also a trig component. So let's just say, for example, I have 3x, let's say cubed, and then minus the sine of x, sine x, close parentheses, and enter. And so you can see here it returns a value of 9x squared minus the cosine of x, which is what we'd expect. So the nice thing about this is that with the TI-84, at least I have not seen any updated versions where they give a symbolic derivative. You can get a numerical derivative. In other words, you could get the derivative for, let's say, a value of pi or 3 or something like that, and it would give you that, but it does not give you this symbolic derivative. Okay, so that's one function that you can use. Let me clear that, and let's go back to math, and let's look at something with an integral. Okay, so let's look at a symbolic integral. We'll do one of those. And then we'll also do a numerical integral. And for reasons you'll see here in a minute, I'm going to keep it pretty simple. I'm going to have x to the third power plus, I'll go plus the sine of x. And I think I don't need to wrap all that in parentheses. If it turns out it gives me something weird here, I'll go back and redo it. Enter. And so I get x to the fourth over 4 minus the cosine of x. So did exactly what I would think that it would do. All right. So let's do one where we have limits of integration. And so we'll go back to math, and we will pick option number 7. And so it looks pretty similar to the previous one, except this time it gives me a place to put in my limits of integration. I should mention on the previous one, it doesn't say plus a constant of integration. In other words, it doesn't say plus c. But if you're using this, you probably would have already known that that was something you needed to do. Okay, so let's just put in the same thing, and this time we'll put in our limits of integration, x cubed plus, oops, okay, so let's see, delete back one. With it oriented this way, it always takes me a minute to, there we go. Okay, you have to hit the right arrow and get it down a notch. I lost my 3. plus, struggling here. There we go. Plus sine x, close parentheses. Now, I'm going to hit the right arrow button, right arrow button, right arrow button. I'm going to keep hitting it until I see that there we go. Now you can see the cursor is down in the lower box. So let's just say we're going from 0 to, let's say 5. Okay, so it's going to calculate this integral for those limits of integration. Enter. And so it gives me the value 156.966, rounded to 3 decimal places. Okay, so that's all fine and dandy. Let's look at something that I was trying earlier today, and this is what I wonder if anybody has a workaround for it. Okay, we're going to do, and I found that it's the same also if I'm trying to do it with limits of integration. But let's say I'm doing the symbolic integral again. But this time I got something a little more complicated. So I'm going to wrap it in parentheses, and it's not going to be super, super tricky. But all I want is x divided by sine x. X divided by sine x. Sine x. Close parentheses. And then close another set of parentheses. And enter. Okay, and I have hit enter. And I sit here, and then this is what I get. Operation is not supported. So I thought, well, it might be something to do with using the division symbol. I don't think that's it. But if somebody does know a workaround on that, for example, if there's a way to put fraction form here where I could just have x in the numerator, sine x in the denominator, and it likes that better, I'd be very interested to hear any input that somebody might have. For basic calculus problems, nothing too tricky. This could be something that's really helpful for, at least like a Calc 1 student or somebody that's doing engineering applications, things like that. It can give you the information that you need. So hopefully this helps you. And again, if you have some insight on how to work around that problem that I mentioned, I'd love to hear from you.